In this video, we are going to discuss few problems on angle between the surfaces. Find the angle between the surfaces. Between the surfaces, x square plus yz is equal to 2 and x plus 2y minus z is equal to 2 at the point 1, 1, 1. Now we are going to find the angle between the given two surfaces. First we are going to write the formula cos theta equal to del phi 1 dot del phi 2 by modulus of del phi 1 into modulus of del phi 2. This is the formula to find the angle between the two surfaces. Okay. Now we are going to calculate del phi 1, del phi 2, modulus of del phi 1 and modulus of del phi 2 from the given equation. Okay. First write clearly phi 1 and phi 2. Phi 1 is x square plus yz minus 2 is equal to 0. And phi 2 is equal to, we can write x plus 2y minus z minus 2 is equal to 0. From these two equations, we are going to calculate del phi 1 and del phi 2, and then from that del phi 1 and del phi 2, we can easily calculate modulus of del phi 1 and modulus of del phi 2. Okay. First we can calculate del phi 1. First write the expansion of del, which is I vector into rho by dou x plus k vector into rho by dou y plus k vector into rho by dou z into phi 1 x square plus yz minus 2. Okay. This phi equation is common for all the three terms. First you multiply with each term. I vector into dou by dou x of x square plus yz minus 2 plus j vector into dou by dou y of x square plus yz minus 2 plus k vector into dou by dou z of x square plus yz minus 2. Now we are going to differentiate one by one. In the first term, partially differentiate with respect to x, which is I vector into dou by dou x of this equation. Now differentiate with respect to only x. The differentiation of x square is 2x. In the second and third term, there is no z, which is 0. Plus j vector into dou by dou y of this one, which means partially differentiate with respect to y, only y. In the first term there is no y, which is 0, plus differentiation of y will be 1 here, z is there, right here z minus 2, which is 0, plus k vector into differentiate with respect to z. In the first term there is no z, which is 0, plus z will be here 1, we will get only y, plus 0. Okay. Now we can write 2x I vector plus z j vector plus yk vector. Now we are going to calculate del phi 1 at the point is given here 1, 1, 1, which means substitute in this equation x is equal to 1, y is equal to 1 and z is equal to 1. Substitute here. 2 into 1 I vector plus 1 into j vector plus 1 into k vector is equal to, we can write 2I vector plus j vector plus k vector. Okay, which is the required del phi 1. From this del phi 1, write modulus of del phi 1 equal to, we can write root of this 2 square plus here 1 is there, which means 1 square, plus here also 1 is there, 1 square equal 2 square is 4. 4 plus 1 plus 1, which is root 6. Okay, modulus of del phi 1 is root 6. In the similar way, we have to calculate del phi 2 at 1 comma 1 comma 1 and also modulus of del phi 1 from the del phi 2 from the given phi 2. Okay, del phi 2 equal to, we can write, first you write the expansion for this del, I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into phi 2. Given phi 2 is this one, x plus 2y minus z minus 2. X plus 2y minus z minus 2. This phi 2 is common for all the three terms. Now multiply with each term. I vector into dou by dou x of x plus 2y minus z minus 2 plus j vector into dou by dou y of same phi 2 x plus 2y minus z minus 2 plus k vector into dou by dou z of x plus 2y minus z minus 2. Now we are going to differentiate one by one. I vector into dou by dou x of this phi 2, which means partially differentiate with respect to only x. Here we have to consider the other two variables y and z are temporarily considered as constant. Okay, the differentiation of x will be 1. In the second term there is no x, 0. The third term also there is no x, 0, 0. Plus j vector into dou by dou y, which means partially differentiate with respect to y. Here we have to consider x and z. Other two variables are constant, temporarily considered as constant. In the first term there is no y, which is 0 plus differentiation of 2y is 2, 0, 0. Because there is no y in the remaining two terms. Plus k vector into dou by dou z, which means partially differentiate with respect to z. Here we have to consider the other two variables x and y are constant. Dou by dou z means in the first two terms there is no z, 0 plus 0, here minus 1 plus 2. Okay, simplify this one. I vector into 1 plus here 2 will come, 2 into j vector minus k vector, which is the required del phi 2. If we substitute the given point here, 1 comma 1 comma 1, we have to calculate del phi 2 at 1 comma 1 comma 1 also. But in this del phi 2 there is no variables, which means again we will get the same I vector plus 2 j vector minus k vector only. Okay, from this del phi 2, now write the modulus of del phi 2. Modulus of del phi 2 equal to, we can write root of 1 square plus 2 square plus minus 1 whole square equal to, we can write root of 1 plus 4 plus 1, which is root 6. Okay. Now substitute all the values in the formula. We know that the formula cos theta equal to, one second, rewrite the formula here. Cos theta is equal to del phi 1 into del phi 2 divided by modulus of del phi 1 into modulus of del phi. Substitute here. Del phi 1 is 2i plus j plus k. 2i vector plus j vector plus k vector dot del phi 2, this is del phi 2, I vector plus 2j vector minus k vector divided by modulus of del phi 1. Modulus of del phi 1 is root 6, this one, right here, root 6 into modulus of del phi 2 also root 6, substitute here. taking dot product for these two equations, we can write this. First we have to multiply this into this into this, and this into this. Okay. 2i into I will be 2 because I dot I value 1. But 2i into 2j will be 0 because I dot j values are 0. And also 2i into minus k also 0 because I dot k value is also 0. That's why we are getting only 2 here. In the second term also you multiply with this j with each term. J into I will be 0. J into 2j will be 2. And j into minus k will be 0 because j dot k values are 0. And then multiply with this k dot I 0, k dot 2j 0, k dot k only 1, we will get minus 1. Okay, divided by root 6 into root 6 is 6. 4 minus 2 plus 2, 4. 4 minus 1 is 3. 3 by 6. 3 by 6 is 3. Okay, therefore, cos theta equal to, we can write 1 by 2. From this, we can write theta is equal to cos inverse of 1 by 2. Value for this one is 5 by 3, which is the required answer. Next problem. Find the angle between the surfaces surfaces x log z is equal to y square minus 1 and x square y is equal to 2 minus z at the point 1 comma 1 comma 1. First, write clearly given phi 1 and phi 2 equations. Phi 1 is y square minus x log z minus 1. From the rewrite this equation, write one side all the values, and phi 2 is equal to, you can write x square y minus 2 plus z. Okay, this term 2 minus z goes to left hand side. We can write in this form. As usual way, we are going to calculate del phi 1. Del phi 1 is equal to, what is the expansion of del? I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into phi 1. Phi 1 is y square minus x log z minus 1. Okay, now we are going to differentiate one by one. I vector into dou by dou x of y square minus x log z minus 1 plus j vector into dou by dou y of this into this, and then second term into this, then third term into this. Dou by dou y of y square minus x log z minus 1 plus k vector into dou by dou z of y square minus x log z minus 1. Now differentiate with respect to x. The first term there is no x, 0. X will be 1 minus log z, here constant, you write here minus log z. Minus 1 will be 0 plus j vector into, differentiate with respect to y, 2y. The second and third term there is no y, which is 0 plus k vector into dou by dou z. Y square 0, first term 0. Here the differentiation of log z is 1 by z. Here x constant, you write x by z. Minus 1 is 0. And then substitute here 1 comma 1 comma 1. I vector into minus log 1. The value of log 1 is 0, we'll get only I vector. 2 into y will be 2j vector. X by z mean x and y values are 1 only. We will get only log 1 value. In the first term log 1 is 0, we will get here 0, not I vector. 0 I vector plus 2j vector. Substitute here 1 we'll get only minus k. From this calculate modulus of del phi 1 equal to, we can write 2 square minus 1 square, which is root 5. Okay, in the similar way we can calculate del phi 2 also. Write the expansion of del phi 2 here, which is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into phi 2. Given phi 2 is x square y minus 2 plus z. Now we are going to differentiate with the each and every term. Listen to this and then I vector into dou by dou x of this one. Partially differentiate with respect to x, which is 2xy. In the second and third term there is no x, which is 0, plus j vector into differentiate with respect to y. Y will be 1, we will get only x square. Second and third terms are 0, plus k vector into differentiate with respect to z. In the first two terms there is no z, which is 0, it will be 1 because z will be 1. Now substitute here del phi 2 1 comma 1 comma 1. X, y, z values are 1 1, which is I vector into 2 into 1 into 1 plus j vector into 1 square, that is 1, plus k vector. You can write 2i plus j vector plus k vector. From this we can write modulus of del phi 2 equal to root of 2 square plus 1 square plus 1 square root of 4 plus 1 plus 1, which is root 6. Okay. Now substitute all the values in the formula. We know that the formula, which is cos theta is equal to del phi 1 dot del phi 2 by modulus of del phi 1 into modulus of del phi 2. Del phi 1 is 2j vector minus k vector. This is del phi 1. Del phi 2 is 2i plus j plus k divided by modulus of del phi 1 is root 5. Root 5 modulus of del phi 2 is root 6. Now taking dot product for these two equations, there is no a zeroth term, ith term. Ith term is 0 here, which means 0i here. 0i into 2i will be 0. Okay. This into this. 2j into j will be 2. Minus k into k will be minus 1. Divided by root 5 into root 6 is root 30. Answer is 1 by root 30. Therefore, cos theta is equal to 1 by root 30. From this we can write theta is equal to cos inverse of 1 by root 30.